Hey everyone, and welcome back to The Explainer. So, today we're unpacking a pretty universal and, let's be honest, often totally overwhelming sensory experience. Have you ever walked down the street or stepped into a room and been instantly hit by that heavy, lingering, absolutely unmistakable scent? You know the exact one I'm talking about. It's the kind of scent that can clear a room or just permanently stick to your clothes for hours. But have you ever stopped to ask yourself what exactly is happening on a microscopic level to create that potent cloud? Or why a place smells so incredibly bad after cannabis is smoked there? Today, we are putting that odor under the microscope.
Okay, let's dive into this because this isn't just about a bad smell floating in the air. It's actually a fascinating molecular detective story. For a really long time, even top scientists were kind of baffled by exactly what gave this specific plant its notoriously pungent, skunky aroma. So our goal today is to track down the real culprit behind the stench. And to do that, we have to look past the obvious suspects and dig into the actual, literal chemistry of the plant.
Section 1. The plant's perfumers terpenes.
To find our culprit, we first need to meet the initial group of suspects in our microscopic journey, terpenes. Now, you might assume that the raw plant is just inherently foul-smelling from the get-go, but actually it isn't. The primary aromatic compounds in the plant are a massive family of molecules called terpenes. You can think of terpenes as the natural perfumers of the botanical world, and they're incredibly common everywhere in nature. For instance, you've got myrcene, which gives off a really earthy herbal scent. Then there's limonene, which, as you can probably guess, smells exactly like citrus and lemon. Pinene smells just like a fresh pine forest, and linalool gives off this really soothing lavender aroma. Now, think about that for a second. If the plant only contained these terpenes, it wouldn't smell like a skunk at all. It would actually smell like a genuinely pleasant, refreshing mix of a pine forest and a citrus grove. So, if the terpenes aren't causing that infamous stench, what on earth is?
Moving on to Section 2. The true culprit, sulfur. All right, here's the plot twist. We actually have to shift our focus completely away from those pleasant, fruity terpenes. The true culprit behind that notoriously sticky, skunky odor is an entirely different elemental beast altogether. Let's formally introduce the villain of our story. Back in 2021, there was a major scientific breakthrough. Researchers pinpointed a specific family of chemicals hiding out in the plant called Volatile Sulfur Compounds, or VSCs. And hidden within that family, they found the master offender, a specific molecule known as 3-methyl-2-butene-1-thiol, or, thankfully, 321-MBT for short. What is absolutely mind-blowing about this discovery is that 321-MBT is chemically identical to the primary compound found in the defensive spray of an actual living skunk. I mean, it's not just a similar smell. It's the exact same chemical architecture. No way, right?
Section 3. Why we hate the smell.
Now, what's really interesting about this slide is it brings us to a really important question. Why does this specific sulfurous smell bother us so deeply? Why does it instantly make us wrinkle our noses and just want to walk the other way? To understand this, we've got to transition away from botany and get into the absolutely fascinating evolutionary biology of the human nose. It all comes down to the sheer, incredible power of our biological sensors. We don't measure our sensitivity to these volatile sulfur compounds in normal amounts. We measure our ability to detect them in parts per billion and sometimes even parts per trillion. To put that into perspective, if there is just one tiny molecule of this skunky sulfur floating in a billion molecules of regular air, your nose is going to catch it. We are biologically hardwired to be hypersensitive to this specific chemical. And this extreme sensitivity brilliantly illustrates why our brains are wired this way. Throughout human evolution, a sulfurous odor usually meant one of three very bad things: decay, danger, or poison. Think of rotten eggs, decomposing matter, or obviously the warning spray of a skunk. Our ancestors who could detect those faint sulfur smells and avoid them right away, well, they were the ones who survived. So when you smell that cannabis cloud, you aren't just smelling a plant. You are literally triggering an ancient evolutionary alarm system in your brain that is screaming at you to avoid a perceived biological hazard.
Section 4. The heat amplifier.
Let's move to and see how this builds, because there is another huge layer to this puzzle. If the raw plant has these skunky molecules in it, why is it that just walking past a growing plant isn't nearly as bad as walking into a room where it's just been smoked? To answer that, we have to look at the physics of smoking. Heat acts as a massive, massive amplifier. When the plant is ignited, the temperature rapidly spikes to anywhere between 600 to 900 degrees Celsius. This intense heat causes a violent, massive release of all those volatile sulfur compounds into the air all at once.
But more importantly, combustion creates smoke, and smoke is absolutely full of sticky tar and fine particulates. These tar particles basically act like tiny little sponges, soaking up the sulfur molecules and firmly anchoring that stench to your clothes, the furniture, the curtains, the walls, the whole shebang. The heat vaporizes the stank, and the smoke physically traps it in the environment, which is exactly why a room smells so incredibly bad, and why the odor lingers for hours or even days after smoking.
Which leads us to Section 5, Smell versus Psychoactive Effect. Now we're arriving at probably the most critical takeaway of this entire explainer. We need to completely separate the physical smell you experience in the air from the actual biological realities of the plant's active ingredients. Because honestly, our noses are playing a massive trick on us here. So the crucial point is this. The famous active ingredients, THC, which is psychoactive, and CBD, which is regulative, are actually completely odorless. Like literally zero smell. If you were to isolate pure THC or CBD, they just look like a clear oil and have no scent whatsoever. On the flip side, the volatile sulfur compounds and terpenes that create that massive room-clearing odor are absolutely non-psychoactive. They simply cannot affect your brain's cannabinoid receptors. Basically, the things you smell don't affect your mind, and the things that affect your mind don't have a smell. And this totally reframes the realities of secondhand exposure. If you're just walking down an open street and you catch a passing whiff of that skunky smell, those pure odor molecules are biologically harmless. Simply catching a whiff of the sulfur on the breeze won't get you high, and it definitely won't cause intoxication. Smelling the plant is fundamentally not the same thing as absorbing its active chemicals. However, and this is a big however, you do have to be really careful in trapped, unventilated rooms. In a closed space, you aren't just smelling the harmless VSCs anymore. You are potentially inhaling trapped smoke particulates, carbon monoxide, and trace amounts of vaporized THC. So it all boils down to this fascinating molecular illusion. When we encounter that distinct cloud, our noses are just vastly overreacting to a loud, stinky, but ultimately harmless sulfur alarm bell. Our evolutionary wiring just totally takes over, making us fixate heavily on the skunk smell, while the actual active ingredients, the THC and CBD, remain entirely invisible ghosts floating in the air. And that brings our molecular investigation to a close. It really is amazing how a little bit of chemistry and evolutionary biology can completely change how we perceive the everyday world around us. So I'll leave you with this final thought. Next time you catch that sudden skunk-like scent on the breeze, will you just wrinkle your nose at a nuisance? Or will you picture those tiny, microscopic sulfur molecules, identical to a skunk's defense, expertly triggering an ancient alarm system built right into your DNA? Thanks so much for joining me on this explainer, and hey, keep staying curious about the incredible science hiding right under your nose. See you next time!